Today we'll talk about or look at some different examples of expected values. Our expected value, and expected value is it's almost like what it sounds like. It's the amount or the value that you would expect to get from playing a game or engaging in a activity that deals with some type of probability. So I just have a couple of examples here, and we'll just try to get through as many as possible. All right, so the first one says a $20 bill, two $10 bills, and three $5 bills, and four $1 bills are placed in a bag. If a bill is chosen at random, what is the expected value for the amount chosen? Well, if you recall, expected value is the probability times the amount that you are expected to win. So for each of these things, we need to find the probability of them. So let's do that first. So I already have my pen up. So we have $20 bills. So we have one $20 bill. We have two $10 bills. We have three $5 bills and four $1 bill. So if we add up all of these values, 1 plus 2 plus 3 plus 4, we get 10. So there are 10, my outcome, there's a total of 10 outcomes that I can get. So the probability of me pulling out a $20 bill would be, so we'll put the probabilities on this row here, would be 1 out of 10. The probability of me pulling a 2 out would be a 10 out would be 2 over 10. The probability of me pulling a $5 bill out would give me 3 out of 10. And the probability of me pulling a $1 bill out would be 4 out of 10. So expected value sometimes looks like E of X would be, so for the first one, it would be the probability, which is 1 out of 10. Oops, forgot the 1. Times the amount, which is $20. Plus 2 out of 10. So I'm just adding up the probabilities and the amount. And I would get $10. And I don't have to put the money sign. Then I have 3 out of 10. And $5. And so I'm going to come over here. 4 out of 10 times $1. So when I multiply and add everything up, I get $5.90. So the expected value or the expected risk that I can, or the expected gain that I can have for playing this game or reaching my hand in this bag would be $5.90. All right, let's go to the next one. All right, so now let's talk about flipping a coin. It says in a game, you flip a coin twice. You record the number of heads that occur. You get 10 points for 2 heads, 0 points for 1 head, and 5 points for no heads. What is the expected value for the number of points you'll win per turn? So again, we need to figure out what are the different outcomes that I can have. So if I know if I flip 2 coins, I know that the different outcomes would be I can either get 2 heads, so I can get a head and a head. I can also get a head and a tail, and I can also get a tail and a head. So this would be the first toss, and this would be the second toss. And then I can also get a tail and a tail. So that looks like it's about 4 different possibilities, right? So out of those 4 different possibilities, it says that I get 10 points for 2 heads. So my probability of this would be 1 out of 4. So I'm going to come down here and actually write it down. So my expected value would give me 1/4. And they said that I win 10 points for that. Plus, if I get 0 points for 1 head, so I have 1/4 here for this probability and 1/4 here. So I can either put these together and make it 2/4 or 1/2, because 1/4 plus 1/4 equals 2/4, which reduces to 1/2. or I can write it out each individual one. It doesn't matter because I'm multiplying by 0 anyway. When I multiply anything by 0, it's 0. But I'll write it out for the sake. So we have 1/4 times 0 plus 1/4 times 0 plus, we can get 5 points for 0 heads. So again, the probability of getting 0 heads would be 1/4. So we have 1/4 times 5. So the expected amount, or the expected amount of points that I should get from flipping a coin, if I multiply this and add them all up together, is 3.75 points. So not money this time. This time we're just dealing with points. All right, let's go to the next one. It says there is an equally likely chance that a falling dart will land anywhere on the rug below. So here's my rug. The following system is used to find the number of points the player wins. What is the expected value for the number of points won? So I'm going to say that each of these blocks, count each of these blocks as a space that they can land on. So if I count them up, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's 15 points. So there's, 15 spots. So my outcome is 15. So then for black, what's the probability of getting the black? 1, 2, 3, 4, 5, 6. Probability would be 6 out of 15. What's the probability of getting gray? Again, is 6, so it would be 6 out of 15. And the probability for getting white is 3 out of 15. So then for my expected value, I would get, so 6 out of 15. The amount of points that I get for black would be 40, plus the probability of gray is 6 out of 15, and the amount of points I get is 20. Really, I don't have to write the white because it's 0, but for the sake of just writing it so we can see what it looks like, I'll write it down. So we have 3 out of 15 times 0. And when I multiply and add everything up, the expected value that I get would be 24. So the expected amount of points that I would get would be 24 points. All right. The next one, it says a mysterious card playing squirrel pictured here offers you the opportunity to join in his game. All right, so just a little bit of a side note, if you see squirrels playing cards and they offer you to play, I highly recommend that you don't play. But, to each his own. It says, to play, you must pay him $2. Okay, so you got to give up $2. And if you pick a spade from the shuffle pack, you win $9. Find the expected value you win or lose per game. So let's see what we will have. So first of all, how many spades are in a pack of cards? Well, there are 52 cards in a deck, and 13 of them are spades. So the probability of me picking a spade would be 13 out of 52. I win $9, but I had to pay $2, so I'll actually just win $7. Then I need to add on the rest of the amount of cards. So 52 minus 13 would be 39. So 39 would be the rest of the cards out of 52. And so this time, instead of plus 2, I'm losing 2. So I had to pay 2, so that's a loss of $2. So then when I put this in my calculator, multiply and add my numbers, my expected value that I get is 25 cents. I don't know if that's worth playing against squirrels. I definitely don't recommend it, though. I'm just being funny. All right, so the next one, it says a dice game involves rolling 2 die. If you roll a 2, 3, 4, 10, 11, or 12, you win $5. If you roll a 5, 6, 7, 8, or 9, you lose $5. Find the expected value you win or lose per game. So for this one, I had to put an extra board out here because I feel like I needed more space to write. So when I roll a die, I know that I have the numbers 1, 2, 3, 4, 5, and 6. And on the second die, I also have 1, 2, 3, 4, 5, and 6. So when I roll a 1 and a 1, I get 2, because this is talking about the sum of the die. And when I roll a 1 and a 2, I get 3, 1 and a 3, 4, 1 and a 4, I get 5, 6, and 7. 2 and a 1, I get 3, 2 and a 2, I get 4, and just go on to so 4, 6, 7, and 8. 3 and a 1, I get 4, 3 and a 2, I get 5, and I just keep going. 4 and a 1, I get 5. 5 and a 1, I get 6. 5 and a 2, I get 7. 5 and a 3, I get 8. And I'm just gonna 6 and a 1, I get 7. 6 and a 2, I get 8. 6 and a 3, I get 9. 6 and a 4, I get 10. 6 and a 5, I get 11. And 6 and a 6, I get 12. Okay, so then going back because I don't remember. 2, 3, 4, 10, 11. 2, 3, 4, 10, 11. So I'm going to circle all the 2, 3, 4, 10, and 11 because they're all worth 5. And I want to know the probability. Also, I know that 6 times 6 is 36. So there's 36 numbers in here, right? So again, 2, 3, 4, 10, 11, or 12. Let's go circle those values. And let me change the color. Oh, I was about to say I don't know how to change it. So I have 1, 2, 3, a 3, 4, 4, 4, 10, 10, 10, 11, and 11. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 out of 36. And I win, I think it was $5. We'll go back and see. Yes, we win $5. All right. So next, we're going to go back and circle the ones if we lose $5. So if we roll 5, 6, 7, 8, or 9, we're going to lose $5. All right. So let's change the color. I don't really, let's do green. All right. So we have 5, 6, 7, 8, and 9. And I actually see a mistake that I made from the first one. Just going back to that one, and I apologize. Forgot to circle 12. So this is actually 12 out of 36. All right. Now let's go back and count the other ones that we just did. And it's really just everything else. So really we could do 12 minus 36, and instead of counting it out, and we get 24 out of 36. And this time we're losing 5. And so when I put that in my calculator, I get negative $1.67. So this is, I'm expected to lose if I play this game. All right, let's see if I have time for one more. All right, so suppose you were given one of 30 free tickets at the beginning of this class period. Suppose at the end of the period, just dreaming, 3 tickets are drawn without replacement. The holder of the first ticket drawn wins $100. The second ticket is $50, and the third is $30. Determine your expected winnings. So my expected winnings, so first 1 out of 30 is the first one. I win $100. So it's without replacement. So this time, the next one would be 1 out of 29 because one left, and I have 50. And then the last one be 1 out of 28 because those are not replaced. Give me 30. So if I multiply this up and add it, I get $6.12. All right, so it says if your neighbor offers